Hi students, welcome to MI Academy. And today in this video we are going to continue the grade 10 chapter 2, Motion in Straight Line, from Speed and Velocity. I have mentioned the grade 10 science playlist link in the below description, so that you can watch the previous videos of grade 10 science. If you have not still subscribed to MI Academy, then click the subscribe button, and turn on the notification bell icon, to all, so that you can watch my upcoming videos without missing. So you all know students, speed is how fast you can travel. It doesn't say in what direction, so as we discussed before, speed is a scalar quantity, so it has only magnitude. It does not have a direction. With that in mind, we will see how we can define speed and do calculations. So as we discuss, students, speed is the distance traveled in a unit time, so therefore when we divide distance by time we get the speed. And also this is the equation for speed. As you know, when an object travels, the distance is given in meters, and the time is given in seconds. So the unit of speed will be meters per second, so this is the normal unit, or what we call the SI unit. And also then, if you take an athlete or a person going a fast walk, usually they cover only a short distance comparatively. So then their traveling is in seconds, and we can easily calculate the speed in meters per second unit. But if you are traveling from one city to another, say Colombo to Kandy or Gaul, then it's a very long distance. Then if you give the speed in meters per second, it will be a complicated value, therefore we use the unit kilometer per hour. The distance is very long, so that's expressed in kilometers, and the time duration is also longer, therefore we use the unit kilometer per hour. So both meters per second and kilometer per hour are units of speed depending on the situation. Then we have something called the mean speed, or average speed. Here we consider the total distance traveled, and the total time duration. Only difference here is we are calculating the mean or average speed for the full journey. So these are the equations and the definition for speed. I hope you all got a good understanding of what speed is, so that we can apply this equation to calculate the speed. So the first example. The data related to the motion of an object will be given in a table form like this. Always the time will be denoted first, and time is denoted by the symbol t, and the unit is given in seconds. And the distance traveled is denoted by the symbol d, and the unit is given in meters. The distance traversed by a certain object at different instances in time is shown in the table below. Now we have to calculate the speed. That means how many meters the object has traveled in 1 second. Okay, now find the speed during the 1 second. First of all, let's write the equation, that is speed equals to distance over time. Now the distance traveled in 1 second is 3 meters, then 3 meters divided by 1 second, then the speed is 3 meters per second. Then now find the speed during 2 seconds. Now the distance traveled in 2 seconds is 5 meters, then 5 meters divided by 2 seconds, then the speed is 2.5 meters per second. Likewise, for how much time duration you can calculate the speed. If they ask the speed during 3 to 5 seconds, then first find the distance traveled during 3 to 5 seconds, that is 16 minus 9, equals to 7, then the time taken is 5 minus 3, 2 seconds, now divide 7 by 2, that is 3.5 meters per second. Remember students, if they just ask you speed, you can calculate the speed by dividing the total distance by total time taken, that is the mean speed. Now let us consider the motion of another object described by the following data table. First of all, let's write the equation, that is speed equals to distance over time. Now the total distance traveled is 18 meters, and the time taken is 6 seconds, then the speed is 3 meters per second. Here the speed in each second is same, or constant. Wait, let me show you. The speed of the object during the first second is 3 meters over 1 second, that is 3 meters per second, then the speed of the object during the second is 6 meters over 2 seconds. That is 3 meters per second, then the speed of the object during the third second is 9 meters over 3 second, that is 3 meters per second, likewise fourth, fifth and sixth seconds also the same speed 3 meters per second. Therefore, in this case we can say that the object has moved at a uniform or constant speed. Now we will go on to the next topic, that is velocity. So as I said, velocity is also a vector quantity, that means it has a magnitude and a direction. Velocity also deals with the speed or the how fast an object travels, but here it is in a certain direction. So to calculate velocity, the displacement is divided by time. This is the equation, so displacement will be written in the unit meters, and time will have the unit second. Therefore velocity will have the unit meters per second like speed, but this will have a direction. We can say velocity is the rate of change of displacement. Now we will do some calculations in relation to velocity. Here the data starts at initial time, that is 0 seconds. And the initial position 0 meters, so here you can see the table below shows the displacement of a body along a specific direction. So here they have mentioned that it is along a specific direction and each time interval is 1 second, so if we are to calculate velocity we will write velocity equals displacement over time. Final position minus initial position divided by time 1 second, so that is 3 meters divided by 1 second, it will be equal to 3 meter per second. Similarly if we calculate for the second. Final position minus initial position divided by 1 second, so again 3 meters divided by 1 second, 3 meters per second, likewise for third second. And fourth second also it's going to be 3 meters per second, and all in the same direction. So therefore the velocity of this object has not changed, the magnitude is the same 3 meters per second, and it is traveling in the same direction. Therefore we will be calling this as uniform velocity or constant velocity. So here you can see when a body is moving at a constant velocity or uniform velocity, neither the magnitude nor the direction of its velocity changes with time. So when both the magnitude and the direction are the same, the velocity is called uniform velocity or constant velocity. If we look at an example, a body moves along a straight line with a constant velocity of 6 meters per second for 5 seconds, what is the displacement of the body? So as you all know, when we calculated the velocity we divided displacement by time, so if I write the equation again, velocity equals displacement divided by time. Now if you take time and multiply velocity on the other side, you will end up with displacement, so velocity into time will give you displacement. That is only when the object is moving with constant velocity, so here you can see the velocity is meters per second and the time is 5 seconds. So here the displacement equals velocity into time, so here 6 meters per second into 5 seconds, that is 30 meter. Now we will look at how to calculate the mean velocity. The following table shows the displacement of another object moving on a straight line, as measured during each 1 second time interval. The displacement of this object is 4 meter in the first second, 3 meter in the second, and 2 m in the third second. As the displacement is not the same in every second, the velocity of the object is not uniform. In such occasions we can calculate the mean velocity. Then the displacement is final minus initial, that is 12 meters minus 0, and the time is 4 minus 0, that is 4 second, then the velocity is 12 meter divided by 4 second, that is 3 meters per second. Now we'll go to the next example. The variation of the displacement measured with respect to the starting point of a child riding a bicycle on a straight path during each 1 second time interval is shown in the table below. So if you look at this data, they have given you the displacement with time, and you can see there are different regions where there is a difference in displacement. For example, if you take this region from 0 seconds to the 4th second, you can see that the displacement is changing uniformly to 4, 6, 8. And if you look at the values carefully, the displacement during each second is going to be 2, but from the 4th second to the 8th second, you can see the displacement is the same value. It is at 8, the object is at the 8 meter position and it is not moving, therefore we call it as the object is at rest. Then if you look at the last few seconds, you can see again from 8 seconds to 10 seconds, again the displacement changes and it decreases and comes back to 0. So since displacement has a direction from this data, you can understand that the object moved in one direction first, then it did not move, and thereafter it moved backwards to its original position. So this is the information that you can get from this data. Using that we will do the calculation. So the first question is, what kind of motion has the child undergone during the first 4 seconds? So as I told you before, here you can see the displacement is the same value, 2 meters in each second. So that means the child moved with constant or uniform velocity, so we will have to say child moved with constant velocity. Then the next question is, what is the rate of change of the displacement during the first 4 seconds? Rate of change of displacement will be displacement divided by time. So here if we take the total displacement within the first 4 seconds, it is 8, so 8 meters divided by 4 seconds, that will be 2 meters per second. The next question is, give one word to describe the rate of change of displacement. You all know, children, the rate of change of displacement will be velocity. What can you say about the motion of the child during the time period from 4 seconds to 8 seconds? We saw this in the table. From 4 seconds to 8 seconds, the displacement does not change. That means the child does not move, so you can write the answer as child does not move, or you can say child is at rest. The next question, describe the motion during the time interval from 8 seconds to 10 seconds. The initial position was 8 meters and then again the child is back at 0 meter. This is the final position. So here you will have to say the child moved in the opposite direction and reach the initial position, and find the velocity of the child during the last 2 seconds. So here displacement is calculated as final displacement minus initial displacement, so 0 minus 8 meters, divided by time 10 minus 8 seconds, that is going to be minus 8 meters divided by 2 seconds. So our final answer is minus 4 meters per second. So here you can see this value is a negative value, and the negative sign indicates that the child moved in the opposite direction. I hope you understand the significance of direction in relation to velocity. Okay students, we will continue the chapter 2, motion in straight line, from acceleration in our next video, so please subscribe to MI Academy, and turn on the notification bell icon, to all, so that you can watch my upcoming videos without missing. Also please, like my videos, and add up your questions and doubts in the comments. I will try to reply them as soon as possible. Share the videos with your friends, and help them to learn.